Okay, so the next section, we're now looking at inclined planes. And what's the big difference really from this diagram? Well, we've moved away now from things typically sort of maybe being on a table, yeah, where we just had vertical forces and maybe forces to the left and the right, and our sort of our axes have been tilted, if you like. Okay, so it might be a bit more like this. Now, we could, if we really wanted to, we could picture all of our forces and we could make them like this, but that's not the approach that we're going to go for. Okay, so instead of now talking about forces being vertical and horizontal, we're going to talk about forces being parallel. So parallel, I mean this sort of direction here, up the slope, down the slope, and perpendicular. So this way, so into the slope and away from the slope. And if we do this and we break every force either into one of those or one of those, we will be able to do things very much in the same way as before. Okay, so to remind you, before, for vertical, you would have your own situation going on here, which might be something like equilibrium. So before we had things like up equals down, and that was completely separate to what we were doing horizontally. So in the previous video, for example, we had to do F equals ma because something was moving horizontally. So it had no acceleration vertically, but it had acceleration horizontally, and they were separate things. And these will also be separate things. So what happens parallel to the slope is going to be completely separate to what happens perpendicular to the slope. I know I'm making quite a big point of this, but this really is quite an important concept to understand. So with that in mind, what forces are acting on this block? Well, it's on a slope, which is still sort of like a table. So there's still going to be a reaction force. Reaction forces, they don't just go straight up, they are perpendicular to a plane. So when you have a table and you had a block like that, perpendicular to this happens to be an up arrow. Here is not an up arrow anymore. What other forces are there? Well, weight is going to go just straight down. So you might sort of see a problem with this. It's not really matching. So the reaction force, we actually quite like the way that this is drawn. The weight, we're going to have to resolve that. And you sort of saw that in the previous lesson. So we're going to make it into parallel and perpendicular components. So look at how the right angle triangle has been made. And it's been made in such a way that you've got perpendicular here and you've got parallel there. So your triangle has to achieve this. The angle, so we could prove this, but we're not going to do that right now. The angle in here will be the same as the angle down there. So this will be 25. Now, 12G is opposite your right angle. So 12G, that's the hypotenuse. So do you remember how to talk about the other sides using the hypotenuse and the angle? Well, it was like this. The one that was opposite the angle was sine. So it's the hypotenuse, which is 12G, not 12, 12G. 12G sine 45, 12G sine 25, sorry. And the adjacent side is 12G again, cos 25. Okay, and once you've done that, if you wanted to, you could then even sort of ignore that one there from your diagram. Okay, so you've now got all the forces on it. So you've got the reaction force going away, you've got the force acting into the slope. If you're wondering what that is, why is it going into the slope? That's the component of its weight that's acting on its slope. So if you put something heavy on a slope, some of it acts into the slope, doesn't it? And then some of it acts down the slope, which is this one here. So if there's no friction on my example here, can you see that, well, these presumably are balanced because they're not accelerating. But this force sort of seems to be on its own and there's no other forces around. So that suggests that this block is going to start accelerating downwards because there's nothing else to work against it. Let's do another one. So what forces are acting on this block? So it's a block again, but there's also this force here. So somebody is pushing the block in this sort of way. So what's acting on the block? Well, it would be the reaction, the weight. So the weight, as before, goes straight down, and then you draw the triangle to break it up. So opposite is going to be 12g sine 25. Adjacent is going to be 12g sine 25. I've now dealt with that, so I'm going to get rid of that. So how to handle this force here that says P? Well, you've got to draw a right angle triangle that will give you parallel and perpendicular. So how would that be drawn? Well, it would be something like this. So I'm going to make the arrows add together. The angle, this angle will be 25. Why is it 25? Well, look at that blue arrow and look at the base there. This is angles in a parallel line. And then you can do the same thing that you did before. So the bit that goes down, must be P sine 25. And the bit that goes parallel must be P cos 25. So apologies, the diagram is getting a bit messy at this point. But this force, because it doesn't fit the situation, when it's resolved, it will create two, a sine and a cos. The weight, because it doesn't fit, when it will be resolved, will create two, and R is just there on its own. So there's 5 different, when you break them into components, 5 different forces you could think of. What's the mistake with this one here on the board? Well, it's going to be R, isn't it? So our reaction force should be more like, well, like you can see now on the next one. How about this one here? So what's the problem with this one here? Well, 30, we want the 30 to be up there, okay? So we're going to have 26g, yeah, that sounds okay, sine 30, cos 30. What have we got next? So what's the problem with this one here? Well, this triangle doesn't really seem to be broken into perpendicular and parallel if you look at it. So the numbers don't seem too bad, but really it should be more like this, shouldn't it? Okay, so this is better how it is now. How about this one here? Well, the triangle again, the triangle is not right. So you want to draw the right angle triangle more like this, okay? So you've got your right angle there. Okay, so I'd recommend here sort of just having a go and practicing a little bit what the components would look like once you've broken them all down. So the goal is to make sure that they all go perpendicular or parallel. So every arrow, once you've resolved, if you have to, should fit one of these directions. Okay, so let's do some problems now. So for problems involving inclined planes, resolve forces parallel and perpendicular to the plane. That's what we've been talking about doing so far. A block of 10 kilograms slides down. So slides down implies that the thing is moving. A smooth slope, so smooth, no friction yet in this lesson, angled at 15 degrees to the horizontal. So from that information, you should be able to draw something like this. the force away, the force in. Really, what's on the board now? This is the most basic version of one of these diagrams you will get if you think about it, because this all happens from just having a block on a slope and just leaving it there. Okay, there are no other forces really going on yet. If people start pushing the block or pulling the block or things like that, then there would be more on the diagram. We've got the arrow here for the sliding down. Okay, so let's have a go at the next bit. Calculate the magnitude of the normal reaction on this of the slope on the block. So in other words, they want to know what R is. Well, let's consider then all of the forces acting away and acting into the block, into the slope. Now, the resultant of this is going to be 0, or if you prefer, it means that one equals that one. Why? Because if it weren't 0, it would mean that the block is floating away or is sinking into the slope. So R is just going to be 10g cos 15, and that's all it is on that one. Find the acceleration of the block. Well, they're not talking about this one anymore, are they? Because there's no acceleration here. They must be talking then about what's happening sort of parallel to the slope. So I'm going to call the force downwards, which follows A. I'm going to call that the positive force, and I'm going to find the resultant. So here we go. So 10g sine 15. Now, are there any other forces that are acting down? No. Are there any other forces that are acting up? No. So that's just that then. That is going to be the resultant force. There's no other parts to it. Well, if I do equals MA, so M for the block was 10A. So what you need to do then is you need to do 10g sine 15 divided by 10. And that's going to give you your acceleration, which is just g sine 15, or 2.5. So that's pretty standard what's just happened in that question, that you have the perpendicular resultant being 0, and you have the parallel part being a bit more interesting. In this case, there was an acceleration. Let's do another one. So a particle of mass m is pushed up a slope. So please don't assume that it will always go down a slope. That's not necessarily true. It's inclined at 30 degrees and it's pushed up. So it's pushed up with 5g force, acting at an angle of 60 degrees to the slope, causing the particle to accelerate. Okay, right. So because there's a lot of stuff in here and this looks quite intimidating, what you should just focus on is being able to get this diagram. So this looks pretty difficult, but let's go through and talk about where it all comes from. So R is just R because it's on a slope. We've got this one going up because it says it's going up the slope. And it said it was accelerating with 0.5. What's going on down here? Well, this is the weight, and the weight has been broken up. So M is the mass, mg is the weight. It's been broken up into sine and cos. Okay. Once you've done that, remember, you could just get rid of it now. You don't need that. You've resolved it. This is the external force. So this is somebody pushing on it. So this is a bit more complicated. So how did we draw this one then? Well, we knew that it was a force that was 5g, not 5g. And it said that it was acting at an angle of 60 degrees to the slope. So we should have been able to get that 60 there as well. Then, like we've done in the previous parts, we drew our right angle triangle. The opposite bit is sine. The bit next to it is cos. So I could also get rid of that now as well. So 1, 2, 3, 4, 5. There's 5 parts of forces or resolved forces that we're going to use in this question. Once you've done that, you'll be in a much better position to do this one here. So show that the mass of the particle is this one here. Well, let's use this for clues. So it's got 5g in it. So I definitely want to use one of these forces here. And I need something that's got m in it as well. A fairly decent technique is to write out sort of what's happening perpendicularly and parallel, and then using that to sort of guide you. So let's just try perpendicular first and sort of see what we get. So all of the forces acting away, so that's just R. Any other forces acting away? No. So what can we say here? Well, it's still in contact with the plane, so it must be equal to the down forces. So that's that force there, which is 5g sine 60. And it's this one here, that's mg cos 30. Okay, and that's all the perpendicular forces dealt with. Now, does this help me in this situation? Well, you can see here, no. So I've just shown you that it's not necessarily true with the early questions that both parts immediately get used. However, in the next part of the unit, you're going to see that the part we just did is going to be quite important for most questions. Well, let's do the parallel bit now. So I know that there's acceleration going on. So I'm going to try and make an equation with F equals ma and see what goes on with that. So to the right is going to be positive for me on this one. So do I have any forces going to the right? Yes. mg cos 60. Any other forces going to the right? No. Any forces left? Yes. So that's going to be a negative then. So minus mg sine 30. So that is my resultant force. What's this equal to? It's equal to ma. The m is just m. I don't know what that is yet. Let's do this underneath. Is equal to m, and a is 0.5. So this is the equation that I'm going to have to use to answer this question. So the G's are there, so we just leave them. M is, so I'm looking to get this in the format M equals. Right. Let's bring both M's to the same side, and let's put in the values of cos 60 and sine 30. So let's do that first. So 5g times cos 60, so cos 60 is root 3 over 2, equals, I'm going to put half m at the front, plus mg sine 30. So sine 30 is a half, so that's really just a half mg. If I multiply both sides by 2, then that one's going to disappear, that one's going to disappear, that one's going to disappear. And I could factorize m as well at the same time. So let's do all of that. So 5 root 3g equals, and I was factorizing m, wasn't I? So m, and then that's 1 plus g. Oh, sorry, cos 60. I just realized that cos 60 is not root 3 over 2, is it? It's actually just a half. So that one would be gone there. So these things happen. This is where you look back, you check your work, and you use the show that's to guide you as well. So then I divide both sides by 1 plus g, and I would get m equals 5g over 1 plus g. So you must get to the final result in the show that question. Okay, well, there you go. On the board is a slightly neater version of doing that. Another question. So let's take a look. I think we've revealed some of this, so let's just explain what's going on. So a particle P of mass 2 kilograms, there we go, is moving on a smooth slope and is being acted on by a force 4 newtons that is parallel to the slope. I should say slope, as shown. Okay, so this is drawn for us, okay? And the acceleration is drawn for us. So we don't need to worry about where everything comes from because it's being shown to us. The slope is inclined at an angle alpha to the horizontal, where tan alpha equals 3 over 4. So let's talk about this bit here, because this might be a new part that you haven't seen yet. So sometimes they don't tell you the angle in a question. Instead, they will do something like this. So what are you meant to do in these questions? Well, if you draw a completely separate diagram, so it's got nothing to do with these, okay? It's got nothing to do with these at all. If you draw a separate triangle, you should be able to draw this triangle over here. How? Well, remember that tan means the opposite side over the adjacent side. So if you draw a triangle, right angle triangle, if you call that alpha, that's your opposite side, that's your adjacent side. Look, you can make that triangle there. Now, this is not that slope. This is just a way of working something out. From Pythagoras, we know that 3, 4, 5, whether you work it out or whether you know this, is a common Pythagorean triple. And now you have this triangle, you could use this triangle to work out not tan alpha, but cos alpha and sine alpha, like this. So why? Why would you do this? Well, you've been told, well, you have to anyway, because they tell you tan alpha is 3/4. But it means now that when you're doing your working, when you get cos alpha, you can just substitute that whole thing with the value of 4/5. Similarly, if you're working and you get sine alpha, you don't write sine alpha, you substitute it out for 3/5. Okay? So let's just use that to go through the rest. So this one here, you are going to see this one quite a bit in mechanics. So when they say tan alpha, typically they say tan alpha equals some number. Draw this triangle. Draw this and work these out because you will use these a little bit later in the question. So they've started by doing the forces. So there's the reaction force. We know how to get that one. There's the 4 from before. It was 2 kilograms, remember? So 2 kilograms, they've broken that into the sine and the alpha part. So I'm going to get rid of that now because I don't need that anymore. Work out the acceleration. So it was accelerating in a parallel way. So if we look at the parallel forces, we can do F equals ma. So all of this bit here is the resultant force. So look, the force is going up. Well, that's just 4. No other force is going up. Minus the force is going down. That's that one there. Must be equal to A. M was 2. Then, for sine alpha, did you notice that they didn't say sine alpha? They said 3/5. So 4 minus 2, G is just 9.8, times 3/5 equals 2A. And then dividing by 2, we get our answer here. It's a negative, but that's fine. Acceleration is a vector. You're allowed to get negative values. That just means that if this is positive, it's negative. It means the thing is slowing down. Okay. So yeah, the main theme from that one then is sort of the tan alpha triangle. Okay. And as in the previous example, we didn't use R and we didn't use the other perpendicular force in this example. So you're now ready to have a go at exercise 5B, and I recommend really spending quite a bit of time on this because you will have exam questions where big parts of them are exactly what we've just done here on the board. And in terms of how to score really highly on them, it's finding perpendicular and parallel equations of motion like we've been doing.